Looking for dr dt. But we're given r in terms of theta, and theta and t kind of. We don't exactly have theta in terms of t. So what we're going to do is we're going to look for dr d theta. We can certainly differentiate r with respect to theta. And we'll have to implicitly differentiate theta and t to get d theta dt. Because between the two of those, if we multiply them, the thetas will cancel, and we'll wind up with dr dt. So what we're going to do is eventually we'll do dr dt is going to equal dr d theta times d theta dt. And so let's find out these derivatives here. Dr d theta is going to equal 1/3 of theta squared plus 7 negative 2/3 times 2 theta. And we'll implicitly differentiate this here, theta with respect to t. So differentiating theta with respect to t, let's see, we've got multiplication here, so it's product rule. So we have the first times the derivative of the second, taking the derivative with respect to t, so that's just 1. First times the derivative of the second, plus the second times the derivative of the first, would be 2 theta to the first d theta dt. So that's taking care of this product. And then derivative of theta with respect to t is going to be the derivative of theta with respect to t equals 1 is 0. So now let's clean up a touch. So that we have 1 that's theta squared plus 2t theta d theta dt plus d theta dt is 0. So we'll subtract theta squared from both sides. We get 2 t theta d theta dt plus d theta dt equals negative theta squared. So it takes care of the bottom there. We'll take out a d theta dt, both these, leaving 2t theta plus 1, negative theta squared. And we'll divide both sides, choosing our object of discerning what d theta dt is, negative theta squared over 2t theta plus. All right. So now we have d theta dt, and we have dr d theta. Not quite sure why I didn't do all this. There's a whole lot to put together just like this and multiply and hope everything comes out. So we're going to evaluate everything and evaluate this. I'm going to say that dr dt at t equals 0 is the same as dr d theta evaluated at t equals 0 times d theta dt evaluated at t equals 0. We're going to evaluate both of these at 0. So let's get ourselves back straight. Huh? Here we go. Dr d theta evaluated at t equals 0 here. So we don't have a t yet. We've got, oh, when I just erased the other one. T equals 0. So that's going to be the same as dr d theta evaluated when theta equals, we just got to get theta in terms of t, which I believe we already have. I'm going to put it so that's looking at theta squared t plus theta equals 1. Rather unfortunate, but we do what we have to. When t equals 0, this all goes out, and that's just sheer luck that that's 0. Otherwise, we have to factor and we get 2 answers, and that'd be horrible. But as this is 0, that means that theta equals 1 when t equals 0. So dr d theta when theta equals 1, now a much simpler problem. So that's going to equal 1/3. Theta equals 1. 1 squared plus 7 is 8. 8 to the negative 2/3 is going to be 1 over cube root of 8 squared times 2 theta, or times 2 times 1. That's going to be 1/3. Cube root of 8 squared is going to be 4. 2 and the 4 will cancel. This equals 1 over 6. So that's dr d theta at t equals 0. So that's this one. Dr d theta at t equals 0 equals 1/6. D theta dt on t equals 0. D theta dt t equals 0 is also terms of this. So t equals 0. So d theta dt at t equals 0. We found out when t equals 0 that theta equals 1. So d theta dt. So that's going to be negative 1 up top. T equals 0 will be 0 over 1. That just equals negative 1. So 1/6 times negative 1 equals negative 1/6. All right. Particle motion. Position at time t greater than equal to 0 of a particle moving along the s-axis is given. All right. We're moving along the s-axis, so that means we're doing a one-dimensional motion with respect to time. You can think of this kind of as a yo-yo. We move along one axis, a yo-yo does, and you can walk the dog, you can do all sorts of things so that the yo-yo might stay here, and then go down, up, down, hang out for a while, up, go in the cat's cradle, swings back and forth, but it goes down. So looking at number 70. So our position based on time is given by 10 times the cosine of t plus pi over 4. All right, so this is a nice harmonic oscillation. Going back and forth, back and forth. At maximum we go up to 10, at minimum we go down to negative 10. Our period is 2 pi, and we start out just a little bit shy of our maximum. Give the parametric equations that can be used to simulate the motion of the particle. Parametric equations used to simulate the motion of the particle. I don't see why we need to put this in terms of parametric equations. That's in terms of t, and it's already straight. I mean, we could do y equals 10 cosine of x plus pi over 4 and have x equal t. I don't really see how that helps. But who knows? All right, so there's A. If the book gives me a different answer, I'll look at it later. What's the particle's initial position at t equals 0? So that's just s of 0, which would equal 10 times cosine of pi over 4 equals 0. Cosine of pi over 4 is radical 2 over 2, so 10 times radical 2 over 2 equals 5 radical 2. So our initial position, that's where we start. What points reached by the particle are the farthest to the left and right of the origin? All right, so this is going to max out at 1. It's going to be a minimum of -1. So we're going to go all the way up to 10, all the way down to -10. Or 10 to the right and 10 to the left. When does the particle first reach the origin? What are its velocity, speed, and acceleration then? When does this first reach the origin? Well, the origin will be 0 for a position. So 0 equals 10 cosine of t plus pi over 4. So that's when 0 equals, divide both sides by 10. Need to inverse cosine both sides. Or to cancel the cosines. Inverse cosine of 0. And we're not quite sure when this is going to happen specifically. So we're going to give a range here, or several values, to see which one's first. T only being positive, I suppose, but we'll figure that out in a second. So that when is cosine 0? Well, cosine is the x value, so we're talking about pi over 2, negative pi over 2, that sort of thing. So do pi over 2, negative pi over 2, 3 pi over 2, negative 3 pi over 2, etc. equals t plus pi over 4. So we subtract pi over 4 from any of these. We're only looking at positive t values. Remember that we said that it's in the instructions. The position at time t greater than or equals 0 of a particle where along the x-axis or s-axis is given by this. So the closest, nearest t would be this one, which when we subtract pi over 4, give us pi over 4. I'm sorry, yeah. T equals pi over 4. Add pi over 4. We're good to go. So that's the time when we first reach the origin. We want to find the velocity, speed, and acceleration. So let's take our first and second derivatives. So our first derivative of speed, our first derivative of position, which would be velocity, would be 10 times negative sine of t plus pi over 4 times the derivative of the inside, which is just 1. That's negative 10 sine of t plus pi over 4. That's our first derivative. So when t equals pi over 4, pi over 4 and pi over 4 is pi over 2. Sine of pi over 2 is 1. So negative 10. So our velocity is the first derivative of position. So our velocity at pi over 4 equals to negative 10. Speed, or speed, s. We already used s. Or speed. No reason we can't have a 5-letter function. Speed at pi over 4 is going to equal the absolute value of the velocity at pi over 4. The speed is just directionless velocity. That's going to equal 10 as well. And our acceleration at pi over 4 is going to equal the first derivative of our velocity at pi over 4. Oh, I'm running out of time. That's that.